Okay, so this is chapter 2, math review. So there's a lot of stuff in this chapter from very easy to fairly hard. It is basically a derivative review and an optimization maximum and minimum review. We are building up to at least one basic concept. It's one basic concept, but it encompasses, a lot of kind of advanced math concepts within one. But one thing that we are building up to here is multivariable functions. So a multivariable function is going to be a function of two or more variables. We literally go over this right now, but y is going to be a function of two variables, not one, but that's x1, that's x2. We do this like dot, 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 x sub n. We're not going to have that in this class. It's just technically in math, it can be infinitely many variables, but another thing that you have in the real world, but not in this class, is like a function of, say, seven variables or something. But multivariable function, which we will talk about again later, and optimization, maximizing, minimizing, mainly maximizing those multivariable functions. It is basically, there's just too much to say, but it is basically just a derivative review. But where is all of it going? All of chapter 2 is really just geared building up to two things. Number one is multivariable functions, and number two is going to be maximizing, minimizing those multivariable functions. See if we can clear that there. Okay, so let's just kind of start from the beginning. Yeah. So a function f is a mapping from a set x called the domain into a set y called codomain. That is, of course, the range. For every element x of x. So this is all very simple. We know this. I wouldn't call the notation advanced, but we just quickly define what they're talking about. This is just, it's almost algebra 1. It's what is a function? Define a function. It's a review of that. For every element x of domain x, the function assigns a single element y of codomain y or range y. The variable x is called the independent variable, and y is called the dependent variable. So that's actually fairly important. We're just saying that y depends on x. It's all very simple, very easy, but could be brand new to some people. The value of f at x is denoted f of x, that is. So we know the function notation there, yes. So when we write y equals f of x, we indicate that there is a functional relationship f between x and y, but we do not always make this mapping explicit. So we don't care about implicit, explicit. Sometimes we will make this mapping explicit. So we do have the terms implicit and explicit. I just get a little bit confused here. We can have either one, implicit, explicit. Yes, implicit. I'm sorry, because I'll get it backwards here. Yes, yes. Explicit. Explicit just means y equals. That's all it means. So explicit just means that y equals the thing over here. Of course, implicit, we do remember implicit differentiation. Yes. Implicit, we can just kind of make something up, means you have xy equals 4 plus x plus y or something. It just means that y is not alone. Yeah. So literally, if we just quickly define it, yes, explicit. Yes, explicit, implicit, explicit is y alone. Yes, alone. And we just move on, already spending too much time on it. But y alone just means implicit, means y is not alone. But a function usually is explicit, which just means y alone. Could be implicit, but we don't really care so much for this book. Yes, but what do they say here? Sometimes we will make this mapping explicit. For example, we can write the function f of x equals 4x, or simply y equals 4x. We don't really need to read all that right there. It doesn't really matter. Yes, so I just want to kind of do a quick review of everything that they just said. I mean, this just shows a y equals mx plus b, a straight line. Yeah, but we know the domain. Yeah, we know the domain is the set of all x. This domain, it's the domain, is negative infinity. Yes, to infinity. Now the range, yes, the range, in fact, let's just write it. We're not going to dwell on this, but whenever they say codomain, I think we already know that they mean range. Range and codomain are going to be the set of all y values, the set of all vertical, yes, the dependent variable range equals codomain, yes. And you input x, so it is therefore independent. The x variable, the input, is independent. And then from x, you get an output, which is y. The y can be called, this is not statistics, it can be called the response variable. Yes, the y, but we call it the dependent. It's not very hard. We call y the dependent variable only because it depends on independent variable x. So we understand things very simple. Oftentimes we're talking about time or money or something like that. So the domain is generally going to be restricted to positive numbers. Yeah, so we get a domain quite often, 0, comma, infinity. Same with the range right there. Yes. Okay, so already we introduce, yeah, we have, those are just two examples of graphs. We don't really need that. Okay, but already we introduce the idea of the multivariable function. Yeah, it says it right there. Let's just kind of read ahead here. So we will often be interested in functions with two variables. Yes, that's going to be a multivariable function right there. Y equals a function of x1 and x2. So for instance, an example, for instance, y equals 4x1 plus 8x2 can represent the amount of apples y, that's the dependent variable, a farm can produce when using different amounts of organic fertilizer, one of our inputs, and artificial fertilizer, x2, the second input. Those are both independent variables. Yes. So in real life, function f might depend on many other variables such as size of the farm and the number of workers. To simplify our analysis, in some cases, we will implicitly invoke the uh, Seritas Paribus. I can't even say it. It doesn't really matter. So we have this basic concept. It really doesn't mean a whole lot to the class, but this is a multivariable function. Yes, as we said a moment ago, y equals a function of x1. We can exaggerate x2, x3, comma, dot, dot, dot. That just means a whole bunch of them that we skipped. X sub n means you can have 7x's, you can have 9x's, you can have 22x's. Obviously, not literally infinitely many x's, but you can have many, many x's. So we don't care about this silly assumption. They're just being silly there. But if you have many, many, many variables, all that's saying right there, and this is how we kind of use it, we ignore all of them. If we have many variables at work, assuming that all of them are held constant, they're no longer there. So assuming that all variables are held constant, they're not changing, we can focus on just one at a time or two at a time. So that's what they mean right there. Yeah. With two variables. Okay, I think we continue here in the next video right here.